This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data with GenAI. In previous session, we have gone through with word embedding. Word embedding, that is like if you are having some sentences, then with the help of those particular sentences, or say if you are having one sentence over there, uh, once the sentence is prime Narendra Modi is the prime minister and dash. So how the GenAI models are able to predict India or any other word which is suitable for that particular sentence. So that is possible because of the transformer architecture, and we have gone through with that. And word embedding is the important part where we have talked about the different, you can say, different dimensions, and because of the different dimensions, like we are having a huge amount of dimension in terms of, say, one word is represented with the help of multiple uh, floating point numbers, and these particular floating point numbers are coming from the matrix multiplications, and we have seen the example as well, huh? So if I want to describe, so it was like that, we are having one sentence, and then sentences are converted into tokens, then tokens are converted into token IDs. Okay, then token IDs are refined with the positional encoding, refined with positional encoding. The position part is added with the tokens which have been generated. So this is important because, like, placing the tokens in a particular series or sequence is very important in order to get the proper context from those tokens, huh? Then it's the time for the attention block. So what exactly is happening inside the attention block? The tokens, these refined tokens, will talk to each other, and then we will be having the contextual tokens, huh? Contextual information is being added over here. So inside the attention, the tokens are talking to each other, huh? And then after attention mechanism, it's time for the MLP, that is multi-layer perceptron. Over here the tokens are not talking to each other, but it will try to get the information from some external word, or like the information is stored somewhere. So from there it is trying to fetch the information in order to provide the outcome. I have quoted the sentence in Narendra Modi is the prime minister of, and if I'm giving this sentence to the GenAI model, it will be able to predict India. Okay, it will be able to predict India, but how this India will come? So, do I have given India information in this particular sentence? Guys, are you able to see India in this sentence? If I'm giving these a set of tokens, or if I'm giving this sentence, then will I be able to get the information about India? But from where the India came? Okay, so it came during the pre-training phase. Like we have given this particular informations, like India is say India's capital is Delhi. So a lot of things have been passed during the pre-training phase, and from that pre-training material, from the stored pre-training data, it is able to fetch the India, and we are able to get the outcome. So MLP is add the knowledge to the context so that we will be able to get the correct output. So it is adding the knowledge to the tokens. Okay. Moving further, once we are able to get the outcome from MLP, the outcome will be look like this: 1, 2, 3, or some floating point numbers. You can take it in this way, say 1.222, then 94.96.223, then 12 point. Guys, please go on mute. So the output will be like this. Say India is having this much of probability. This is the outcome, and say you can say Pakistan is also given. It is having the probability of this one, not the probability, but the output. We are not saying say Sydney is there, or uh, we can take any word. So say Mumbai is there. That can be, that can come. Mumbai is there. Okay. So in this particular way, let me take some more words. Say anything. Okay. So this is the prediction. What this is the output. What we got from the MLP layer, multi layer perceptron, and that can be like this. Okay. So this is the outcome from the MLP. Now, once we add all of these numbers which are given from the MLP, the output is more than 100%, more than 100. So in order to convert these numbers into the probability, what I will do, I will apply a function, mathematical function called softmax, and then I will be able to get the probability. What softmax is will do, so softmax will find out the exponential of each number. Okay, and then those numbers will be added, and each and every number will be divided by that particular sum, and I will be able to get the probability. Okay, so this is the task of softmax. We will be discussing in detail. So in order to get the probability from the numbers which are generated by MLP layer, we are having softmax, and it will convert into the probability. Then after the softmax, we will be having the probability. Probabilities, and you can take it in this way. Okay. Narendra Modi. We will be moving with the same sentence. Okay, so just have a look. Over here it is trying to calculate. So it has given Gujarat as well. Okay, probably like it has given the Gujarat, And over here, if you are able to see, the Gujarat probability is 4.42%, and India's probability is 92.6%. The Uttar Pradesh, Maharashtra, A, Bangladesh, New. Okay, a lot of things are coming. This is the same stuff what we are able to see over here. Huh? Okay, but over here, if you are going to add all of these particular numbers, the sum will be 100. But once we are getting the output from the MLP, the numbers are given in such a way, if you are going to add them, the sum will not be 100. So softmax is applied on top of those particular numbers, then we will be able to get the outcome. Okay, so this is let me show you the presentation. Okay, each and everything what I'm going to discuss, I have tried to club them in the presentation. Okay, so if we are going to revise what we have seen, so this is with respect to this particular diagram. Like, say I'm having the sequence GenAI is changing the, and I'm trying to predict the next word. And yes, transformer architecture is the stuff with the help of what I will be able to predict the next word. Then these particular numbers are converted, this particular sentence is converted into the tokens. Tokens are gen, then AI is changing the, okay, these are the tokens, and then tokens are converted into token IDs. Then we are having one embedding matrix which is prepared during the pre-training phase. And for GPT-3, the size of this matrix is 12288 into 50,256. 50,256 is the 257 is the vocabulary size. This is denoting all the words or all the tokens which are possible in GPT-3 model. And 12288, that is nothing but the dimension or embedding size. Okay, so I will be having this much of features with respect to each and every token. Okay, now once I'm having these particular tokens, then the lookup is done from the embedding matrix to get the values, the static values, to get the static values for these particular tokens. Now Gen AI is changing, so I have done the lookup and say these are the values. Okay, this is, say, first column, this is the first value, and this is 12288. So this is the 12288th value with respect to the GenAI. In the same fashion, I will be having the values for each and every token. So now these are the static embeddings. No context rich meaning is there. It is not able to, like, over here, if I'm going to say like Jenny changing the world, is the having any significance on changing, or is changing having any significance or impact of Jenny? It is not there at this moment, because this is static embedding only. VLOOKUP has done, the lookup has done from the embedding matrix. Moving further, like we know the positional encoding, the positions of these particular tokens is also very important. The position is also calculated with the help of, you can say, position encoding, and this is added on to the static embeddings, and then it is moved to the attention block. Okay, so far what we have seen, say if the size of this matrix, embedding matrix, the size is 12288 cross 50,257. That is the embedding, that is the vocabulary size, and it will be approximate to 617 million. Okay, so this much of, you can say, this much of parameters are from the embedding matrix only. And I have discussed the unembedding matrix as well. Unembedding matrix. And this is nothing but the transpose of this matrix, which is the embedding. So it will be like this, huh? Okay, and this is also equivalent to 617 million. And if we combine both of these two, these metrics, so it will be around 1.2 billion now. Okay, so the GPT-3 model is having 175 billion parameter, 175 billion parameters are there. And these 1.2 billions are from 1.175 billions. Let me show you. If we are going on to the Hugging Face and talking about models and GPT-3, I just want to check. And on to GPT-3, I will be able to get, say, 175 billion parameters model. GPT-3, 16K, 16K, 175 billion. Okay, so just have a look over here. GPT-3 175 billion hyperparameter, 175 billion demonstrator, 175 billion config. Okay, this is nothing but these are the models. Okay, uh, although like these are some fine-tuned models, not the foundation model. Okay, so over here, what I want to say, like we are having 175 billion parameters inside the GPT 3 model, the foundation model, and I'm trying to provide you the insight how these particular 175 billion parameters are calculated. So 1.2 billion is from the embedding matrix and unembedding matrix. Now we will try to discuss more about the next phase. Next phase is nothing but this attention blocks. So this particular concept this particular stuff we have discussed, and now it's the time for the attention block. So inside the attention block we are having three main metrics inside the attention block. If we are talking about the attention block, and let me try to show something about uh, what is there inside the presentation. Okay, so the same diagram, what the same flow what I was discussing. Okay, tokens, token IDs, static embedding, refined embedding. Okay, attention block, MLP. Okay, and then multiply it with embedding matrix. Logits are there. Okay, so softmax will be applied onto the logits. So output of the MLP is nothing, is logits. The output what we got from the unembedding MLP layer, that is nothing but the logits. And logits, onto the logits softmax function is applied, and that will give the probability distribution. Now, moving further, this is like how the softmax is working. Say if we are having three numbers, 2, 1, and zero point 0.01, and if we are trying to calculate the softmax of these particular number, so we need to find exponent of each and every logit, and then sum of that particular exponentials, and divide the exponent to the sum of the exponential sum. Then we will be getting the probability. Like this one is the 65%, this one is 24%, this is around 1%. Okay, so this is what like we can say with the help of like softmax. Now if we are talking about if we are talking about the transformer, then there are three different phases. Pre-processing, the tokenizer phase, what we have discussed, that is giving around 1.2 billion parameters. The inference, that is nothing but the attention block and MLP. And over here, the tokens are inferred based upon the context and based upon the outside knowledge. So inference is done with the help of model, and then post processing. So the output from the MLP layer, that is nothing but the logits. These logits are given to the softmax function in order to get the probability distribution. So this is nothing but like the overview, or you can say the block diagram of transformers, how the things are working. Okay, so with the help of three blocks, we I have you can say shown these particular things. Let's move further. Okay, and this is the diagram what we have discussed. Now moving further, I was, let me take these particular sentence and paste it inside this and more about attention block, attention and MLP. Okay, that's what we are going to discuss in today's session. Now, over here, I have highlighted certain sentences. Okay, uh, say the room was filled with soft and soft warm light. Okay, and this suitcase is very light to carry. Over here, two words are there. One word is there, that is light, and uh, in both of these sentences the light context is different. Over here it is, you can say, specifying that it is with respect to weight. Over here it is with respect to, say, the the illumination. Okay, so uh, the context of light is different. Same is over here only, like I deposit my paycheck at the bank, and the second sentence, we had a picnic on the bank of the river. So in both of these particular sentences, the bank context is different, and it is changing the overall, you can say, meaning of the sentence. The pitch, so the singer has a perfect pitch, so that is specifying the musical tone. And the salesman give a convincing pitch, so sales proposal. Over here what we are able to get from this particular word pitch, and over here it is denoting the cricket pitch. So like if you are if like perfect is there, say if the singer has a perfect, okay, and the perfect and you need to predict, say, pitch. So will you be able to predict with the help of this particular, you can say, word perfect? Okay, until unless the context of each and every word is not, you can say, baked in perfect, we will not be able to get pitch. You can take it in this way. Let me type the simple sentence. uh, 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 so GenAI is changing the, okay, so I'm having this particular sentence, and now if you want me to predict, like by just giving the word the, will I be able to predict the next word? Say that is nothing but the world. GenAI is changing the world. Okay, so based upon this particular word, or you can say token, based upon this particular token I will not be able to predict the next word, and that is something with the GenAI as well. Until unless the entire context is not baked. Try to focus over here, guys. Until and unless the entire context is not baked in this particular word, they I will not be able to predict the next word. Okay, and same thing is happening over here. The context in each and every sentence, the context is different. So we need to bake, we need to bake the context, or in another words, I need to change the embedding of this the so that I will be able to predict the next word. Okay, so this is nothing but the attention block, and inside the attention block, we are going to change the embedding of this particular word, say the, and then like just by you can say going through with that particular embedding, I will be able to predict the next word. And same is mentioned over here. Just have a look. Okay. So over here, what I have mentioned, a context-rich embedding, we will be getting the from the word from the attention block, and MLP embedding changed based upon the facts. Attention to MLP. So these are the multiple blocks. Attention to, because these are the neural networks, and we will be having the multiple blocks over here. Take the last vector of the last word, just focus on to this line. Take the last vector of the last word, okay, multiply it with the unembedding matrix, and we will get the the logit sum. Okay, so over here, this is the last word, or you can say this is the last token of this particular vector, and over here the entire you can say context will be baked based upon this attention block, and just by looking onto this day, the looking onto the values of this day, I will be able to predict. But before before that, I need to bake, I need to you can say prepare this deep in order to predict the next word. Okay, so that is what is happening inside the attention block, huh? Now, attention block. If we are talking about the attention block, then there are certain things that we need to know. Okay. There are three metrics inside the attention block, huh? Let me write. There are three metrics inside the attention block, huh? Attention block. Okay. Uh, or you can think in this particular way, how attention block of this particular diagram, okay, is able to change the embeddings of the given sentence. Okay, and like one more thing, say over here what I have mentioned, this the, okay, this particular the will be baked based upon the context, and how much context it is going to take, that depends upon the context length, huh? Context length. Okay, so inside the GPT-3 we are having context length 2048, huh? It means 2048 tokens are considered in order to predict the next word, huh? You can take it in this way. Inside the GPT-3, the context length is 2048. We are having say GPT-4 inside that, like it is almost 32K. Different models are having the different context length. And what is the meaning of context length? That much tokens are taken into consideration in order to predict the next word. Okay, next token you can say. Okay, so there are three metrics inside the attention block. First one is the query metric. Okay, query matrix, huh? So query matrix, what it will do, So over here, I'm taking, say, this particular sentence. So in this particular sentence, it might be possible, sorry, some tokens are relevant in the given sentence. It might be possible that some tokens are relevant and some tokens are not having any impact. Impact. Okay, so you can take it in this way. Say GenAI is so probably like is not having any significance in order to predict the next word. So what I can say, these are the relevant tokens. So the task for this query metric is which token, which token in the sequence, in the given sequence, are relevant. Okay, you can take in this way. Let me type the another word. Okay, say Elon Musk is the founder of. Okay, so over here, I'm just trying to predict the next word. The Elon Musk is the founder of, say, Tesla or SpaceX. Okay, so I'm trying to predict this particular word, but over here the Musk is having, you can say, correlation with Allen. So what I can say, uh, this is the relevant token. Okay, is and the are not relevant token. These are not having any significance. You can say founder on the token founder. Things are happening in this particular way. So say I'm having this word, Elon Musk is the founder of. So how the things will happen? So it will move token wise token. So onto the Musk, the significance is there on Allen. Okay, and onto is the significance will be checked based upon the tokens which are given earlier to this. Okay, onto the significance will be of these tokens. Okay, and on the founder the significance will be checked with respect to each and every token before this. Okay, it is not like the significance will be checked, say the will be checked, the significance will be checked based upon the founder. It will be checked based upon the prior tokens only. So Musk's is dependent onto the Allen. Allen is not having any prior input, so Allen will be taken as it is, and the significance on Musk will be checked based upon the Allen, and onto the founder, the significance will be checked based upon these particular tokens. Musk Elon Musk is the, and from say Elon Musk is the, so these particular four tokens, it might be possible say these two tokens are having the high significance and is and the is not having any significance. So things are calculated in this particular way. So over here it is this particular, say this is the last token, and onto this like it is checked that which are the tokens in the in this particular sequence which can impact, okay, which can change my embedding. Okay, over here just by the name only we are able to get. It is going to query, it is going to ask, it is going to raise the questions that which are the tokens in the given sequence, which are the tokens. So over here say off is asking which are the tokens in the given sequence uh, relevant to me, okay. So and relevant to me, and how much they are relevant. So this is asked inside the query matrix. So in order to this, we will be having a vector size, small vector size. So now we are talking about this query matrix, like how the calculations are being happening in for the query matrix. So query matrix is of query matrix size, matrix size. Sorry, it is of 128 cross 122 88. This is the size for this particular query matrix. This is the size, and what I have mentioned, like it is with the lower dimensions only 128 features are considered, and this particular query matrix is calculated during the pre-training phase. Calculated during the pre-training phase. Okay, this is also calculated during the pre-training phase. Size is this one, 128 divide multiply by 12288. This is nothing but the embedding uh, size, or you can say feature size of GPT-3. So 128, these are nothing but the features this particular query matrix can have. These are the rows or these are the columns. Now this particular query metric, okay, and this will be you can say multiplied with the embedding. So say this is nothing but wq query matrix, and this will be applied getting the query vector. So this query matrix wq will be, it is multiplied with the embeddings, okay, embedding, and then I will be able to get the query vector. This is nothing but the query vector. Okay, so the size for this query matrix is 128 12288. This is the size, and what is the size of embedding matrix? What is the size of embedding? Over here I'm going to calculate the embedding of one word. Okay, say this is having say 12288, and you can take it in this way. Let me, so over here GenAI is changing the, so I'm going to calculate this D is asking the questions to these particular remaining tokens, like are you relevant to me, and if you are relevant to me, then how much you are relevant to me. Okay, this is asked by the D. Okay, the this is asked by thee, and it is not like with respect to thee, in each and every token will be going to ask. So I'm going to take one token and I'm going to calculate the query vector for each and every token. So over here, say of is asking the question with the help of query matrix, and what I will get the query vector. And we know, like, if the internal part, this 12288 is, you can say, same. If we are going to do the multiplication and internal part of both matrix is same, then yes, we will be able to have the multiplication, right? We know it mathematically, yeah? So, and what will be the output for this? What will be the output for this? It will be 128 cross 1, right? Guys, are you with me? Fine so far?
Yes, sir.
Okay. And please ask if you are not able to consume, if you are not able to get. So what I have mentioned, I'm just going through with the query, the attention block. Inside the attention block we are having three matrix: query matrix, key matrix, and value matrix. So with respect to those particular three matrix, I'm moving, and then I'm going to explain what exactly is being happening inside this attention block. Okay, so query vector is not over here. I will be getting the 128 floating point numbers with respect to each and every token. So this will be happening with all the tokens. You can say, you can take it in this way, like, at this moment v is going to check, like, which token is relevant to thee and how much that particular token is relevant. Same the changing will do, same is will do. And gen ai nothing. Oh, ai is there. Ai is going to check with gen. Okay, so each and every token will check the relevance with respect to the another token in the given sequence. And that's what I have said, like, tokens are talking to each other. Over here, tokens are talking to each other, and based upon their, you can say, conversation, what I can say, the embeddings of these particular tokens are changing. So tokens are talking to each other inside the attention block. So uh, this is the key vector. Now, sorry, query vector. Okay, so over here, with respect to the query matrix, I got these 128 floating point number. That is fine. Now moving further, I will be having the key vector, the another matrix, key vector, key vector, query matrix or key matrix, query vector or key vector. So over here, inside the query matrix, the question is asked. Okay, the question is asked inside the query matrix. Query matrix, but the answer, okay, key vector answers the question asked by query vector. Okay, so you can take it in this way. In the previous, you can say, matrix, query matrix, the is asking the question to changing, are you relevant to me? Okay, over here the changing is saying, yes, I'm relevant to you. Okay, this is nothing but the answer is giving, and this particular answer is given with the help of key vector. Okay, and over here with respect to the key vector, that is nothing but say WK metric. Okay, and this the size for this particular matrix is also the same, 128 cross 1228. The key vector matrix size is the same, and it will be multiplied with the embedding matrix. Okay, and what I will get the 128 floating point numbers. Okay, I will get the floating point numbers. And now what we will do, we will calculate the dot product of these two matrices. We now we calculate the dot product for these two matrices, and higher positive number higher positive number says that the token, like says that these the tokens are having relevance. Let me write it first. Okay, let me show you this stuff as well. Okay, so this is the Curie matrix, and this is the Curie vector, this is the key vector. It is going to ask the question, and over here, like I'm check GenAI, you can take it in this way. GenAI is relevant to GenAI, so this 100 is, yes, this is 100%, and those particular things will not be considered. That particular stuff will not be taken into consideration for further calculation. Now GenAI is not dependent on to the words which are coming after this word GenAI. So rest of this particular thing is crossed. Now GenAI rapidly and onto the rapidly, the impact of say GenAI is say minus 0.23%. Now onto the transform, the impact of GenAI is say 11%, 0.11%. Okay, and onto the industry, the impact of GenAI is say 0.47%, rapidly 0.02% minus. Okay, transform is having 0.2%. Okay, now you can think, you are able to see as well. Say the industry, if we are talking the last if we are talking about the industry is having the impact of say GenAI, which is the higher positive number. Okay, that is nothing but the dot product. And if this is the higher number, then that means these two words are having relevance. If this is not higher positive number or negative number, this one is the negative number, then it denotes like these two words are not having any relevance. Over here, say world will be having the impact of say GenAI 0.18%, rapidly, okay, it is 0.06%, transform is having 0.25%, industry is having 0.26%. So this is nothing but denoting the higher positive number will be having the relevance. Same stuff is mentioned here. Whatever is negative, which are not having relevance and is converted to zero. And over here, the numbers which are in negative, so those particular numbers will be converted into zero, and higher positive numbers, that is giving the more relevance, huh? And calculation of the probability distribution gives us that there is a relation between the key vector and query vector. That's what I have mentioned now. Like once we are having the dot product of these two matrix, then what I will be able to get, I will be able to get the the relevance between the key vector and query vector, huh? Okay, so we are having two matrix. One is asking the question, second one is answering to those particular questions. So answering the questions is the key vector, and asking the question, that is nothing but the query matrix, or query vector. So query matrix is going to ask the question, and key vector or key matrix is going to provide the answer to those questions. We uh, calculate the dot product of these two matrix and got the outcome, and higher positive number, that is denoting the relevance between these two matrix, and negative number, that is like there is no relevance, and further these negative numbers will be converted into zero, and then we will proceed for the calculations, huh? Okay, then over here, like softmax is applied. Just have a look over here. Okay, so these are key query and key matrix. These are, you can say, these the calculations are being happening over here, and the output, or once we multiply key matrix and query matrix, then whatever the outcome that we got, that is in terms of numbers, and we again apply the softmax internally inside this, you can say, attention block as well, in order to get the probability distribution, huh? Okay, so that what is mentioned over here. The dot product gives the random numbers. Now we need to convert these numbers into probability distribution that will be calculated using the softmax. Okay, fine so far.
Yes, sir.
Okay, okay. So moving further, the third matrix, what we are having, the value matrix. Okay, so the value matrix. Now, over here, inside the query matrix, we are finding the relevance. Okay, inside the we are asking the question like, are you relevant to me? Token is talking to another token, are you relevant to me? Then inside the key vector, the token is responding, yes, I'm relevant to you. Okay, so inside the value vector, over here, what we need to add to the embeddings to get the final context rich meaning. Okay, okay, so over here, what is the meaning of this? So over here, say I got the outcome, 0.47. 0.47 is the outcome once we have done once we have calculated the dot product of these two matrices. Okay, that is perfectly fine. Okay, now is the time, like say, inside the token d. Okay, inside this particular token, we have taken this particular token d, we have calculated and finding of, we got the relevance as well, huh? We got the relevance, that say this d is having relevance with respect to changing and Gen AI. Okay, Gen AI and changing is having impact on the word the. So that we are able to get with the help of key vector and query vector. But now what I need to add in the embedding of the, so that this particular context is baked inside the word the. Okay, over here I need to calculate what should be added in the embedding to get the final context rich meaning. Is it fine? Are you able to get what I have written over here? Guys, are you able to get? Are you able to get? Is there any
No,
confusion?
sir. Tell me again, sir.
Okay, okay, fine, fine. So, um, I was calculating. I was going through with this word. Say, Gen AI is changing the world. Changing and this. I was trying to predict the next word. So, in the first metric, what was happened? This particular token asks the question to changing age and say Gen AI, are you relevant to me? Okay, are you relevant to me, or how much you are relevant to me? Each and every token is asking the question to the tokens which are prior to this. So over here, they will be asking the question to changing age and Gen AI. Changing will be asking the question to is and Gen AI. Is will be asking the question to the Gen AI. In this particular way, the calculation will happen parallelly for each and every token. Now he has asked the question with the help of query matrix. The answer it got it will got the answer from the key key metric. Okay, and key metric will say yes, I'm relevant to you. It will answer with the help of key metric. Now we got the relevance. Okay, we got the relevance, and now what I need to do, I need to add something in the embedding of this particular the, and you can take it in this way. Say earlier the embedding of the was say 1.12 1.1 1.2 1.3 1.4. Okay, in this particular way, so minus 1.4. In this particular way, we were having the embedding of this particular token d. Okay, so it was like this. Now, what I need to add in the embeddings of the, so that the context of the prior word will be baked into this. So it will be, so that it will be having the context from the prior words. Okay, and say after this particular, you can say after that I need to decide, say I need to add say point 0.6 0.5 in each and every token, so that like it will be having the context of the prior words. So over here I'm going to add uh, zero point 0.5. It will be like this. So I will be able to get the the revised encodings of each and every token, right? And this value we need to calculate with the help of this value metric. Value metric is matrix is going to provide you the the numbers that will be added inside the token embeddings in order to get the context rich meaning. So GenAI is changing. It will be it will be, you can say, dissolved. It will be having the information inside the div. So this information will be given into this particular token d, and then based upon these particular values that is having the context of prior tokens, I will be able to predict the next word. Is it fine? Are you able to get?
Yes, sir.
So the main agenda, what I need to add in each and every token so that it will be having the context rich meaning, and that is decided by the value matrix, right? Okay, so the value matrix is of size wv, that is of size for value matrix 12288 cross 12288, okay. And this is also, this is coming from what? Pre-training phase only, yeah? During the pre-training phase, this particular value matrix is also calculated, huh? So wv, the size of this particular matrix is this one. Now what I need to do, I need to multiply it with the embedding of each and every token, okay. So each and every token, so I'm taking this value matrix, and then I'm taking each and every token. With respect to each and every token, I'm having 12288, you can say, floating point numbers, and I'm taking one uh, token at a moment. So what I will get, I will get the output as, what will be the output? 12288 cross 1. This matrix will be the output, now now whatever we get, okay, from this particular matrix, whatever we are getting, that will be added uh, to the to the token. You can take it in this particular way. We have taken the GenAI token, GenAI is the token, basically, say, okay. We have taken the GenAI token. So based upon this particular stuff, whatever we get, this will be added, it will be added to GenAI token to get the context, okay. So over here, each and every token will be calculated based upon this particular stuff, like we will be having this for, you can take it in this particular way. WV cross, say, embedding of uh, embedding of is the changing. Okay, in this particular way, like we will be having the calculation for each and every token, and Siddha is taken. Let me mention the. Okay, say we have taken the token in order to have the calculation. So whatever we get from this particular matrix, that will be added to the embedding of the in order to get the context rich meaning. Okay, so this is the matrix what is calculated during the pre-training phase. We have taken one token, and with respect to one token, we are having 12288 floating point numbers. Output what we will get, we will get this particular matrix. So that is nothing but a vector basically. So it will be like this. 1, 2, 3, 4, and this is say the token D. Okay, so we will be having 12288 floating point numbers, and these particular floating point numbers will be added to the say initial d was something like this, you can say, and zero point 0.5 what we got from the value matrix calculation, and this zero point 0.5 will be added to the in order to get the context rich meaning. Okay, that's what I have explained over here. Okay. So you can think in this particular way. uh, Let me show inside the presentation. Okay, so over here we are having uh, world. In the previous world example, world is having the relation with GenAI transform and the industry. Okay, GenAI is having the transform with respect to the industry, and the world is having the relevance to GenAI transform and industry. So so what we need to add to these particular embeddings in order to get the context. So we are having value metrics for each and every token. Now whatever we will get, that will be added to each and every token. So from this we will get what we will get, that will be added to this particular token. From this whatever we will get, that will be added to the transform token, and from this whatever we get, that will be added to the industry token. So what it will be, embedding of the world plus say 0.18 into embedding of the GenAI. So from where this particular 0.18 and 0.25 and 0.26 came. So over here inside this particular uh, table, okay, the world we are calculating what we need to add inside the world to get the context of these particular, you can say, words. So which are having impact, which words are having relevance to world. So inside this world is having relevance to Gen AI rapidly, and transform and industry. Okay, so rapidly, Gen AI, transform and industry, these are the four words which are having relevance. If something is in negative, that will be converted into zero, so uh, that is mentioned say no relevance. Now these four words are having relevance. So what will be the final embedding of, what will be the final embedding? So embedding of the world plus 0.18 into embedding of GenAI that we will get from this, plus 0.25. These numbers are coming from the table. 0.25 into embedding of transform plus 26 into embedding of the industry. So at this moment, I will be able to get the final embedding of the world. Okay. So this particular world is having the significance of these particular tokens. So what are the initial tokens? With the new tokens which have been generated with the help of this value matrix calculation, and I will be able to get the updated, you can say, context rich meaning for the given token. So world will be having this particular context rich meaning, okay, or the embeddings of the tokens will be changed based upon the this particular calculation, right? Is it clear? And I can understand, like, you will, these particular things are new to you, and even if you are able to understand 60 to 70%, that will be more than enough. Uh, why I am going through with these particular sessions? Because you need to understand the internals. If you are not having the understanding about the internals, then it you will be, you will feel these particular things are very tough. Okay, once uh, like we will be having, say, embedding matrix, and we will hear about query metric and key metric, okay, key vector. At that moment we will not be able to recall. Okay, and if we are having the better understanding about the internals, then during the fine tuning phase we will be think in a positive direction, and we will be able to achieve more. Okay, during the fine tuning phase definitely we need to fine tune these particular large language models, GenAI models. So during the fine tuning phase, these particular things what we are discussing will play a critical role. That's why I'm going through with these particular sessions, and having focus onto the internal functionality. Okay, so yes, it will take time to understand all of these particular things in a, you can say, a deeper way. But if you are able to understand 60 to 70%, and then you need to go through with the recordings, then you will be able to digest the content. Uh, just watching, going through the sessions, and if you are not listening the recordings again and again, you probably will not get the entire context. So at this moment, if you are able to get the understanding about 60 to 70%, that will be more than enough. And and that is important from fine tuning perspective as well. Okay, so what I have mentioned, we are having three metrics: the query metric, the key metric, and the value metric. Key metric is asking the question, sorry, query metric is asking the question, key metric is providing the answer, and value metric, what should be added in the embedding in order to get the context rich meaning. So over here, each and every vector, each and every token, okay, each and every token's embedding will be multiplied with the value matrix. Okay, and value matrix, we got it from the pre-training phase only. Okay, so whatever the outcome from the value metric, that will be added to the token in order to get the context rich meaning. So over here, the token was 0.18. Okay, the value of this particular token 0.18, and it is multiplied with embedding of the GenAI that we got over here. Okay, okay, so, and all of these particular things will be, you can say, added in order to get the token, the embeddings of the world. Okay, so over here, this is not the predicted word, this is the given sentence. This is the given sentence, and world is having impact on from these particular tokens, say rapid, rapidly, GenAI. So these particular four tokens are having impact onto the world token. So in this particular way, the embeddings will be modified. The embeddings will be modified. Fine? Is it fine?
Yes, sir.
Okay. Now important stuff. Important stuff. So so WQ, that is the query metric. Okay. Query metric size is of query metric size, that is 128 cross 12288. This is the size, and it is calculated during the pre-training phase only, and it is giving me around 1.5 million parameter. Same way we are having query matrix. Key matrix, that is asking the question, that is answering the question which is asked by the query metric. So WK, and the size for this is again 128 cross 12288, and it is giving me 1.5 billion parameter asking question. This is answering to questions, okay. Then we are having value matrix. WV, this is nothing but value matrix. So value matrix, that is of the size for this is 12288, and it is what should be added to get context rich meaning. Now over here, like these two matrices are of size 128 and 12288, and over here this is the size for this particular matrix is 12288 cross 12288. So this is, you can say, the big matrix, and if we are going to have the calculation based upon this, then definitely it is going to consume more resources, and in order to increase the parallelism, what I am having, I have divided it into two parts: value up projection matrix, value up projection matrix, and value down projection matrix. Okay, value up projection matrix, that is the size for this, what it will be, it is 12288 cross this, and if you multiply 128 cross 128, it will be 12288. Okay, so that is fine. So value up projections, that is having more number of rows, and value down, that is almost, you can say, 128 Rows 1, 2, 8. This is value down projection matrix. So if we multiply both of these two, if we multiply both of these two, what I will get? I will get this particular matrix only. Okay, I will get this particular matrix only. So value matrix is further divided into two categories: value up projection, this one; value down projection matrix. The size of the matrix is this one, and once we multiply, we will be able to get the final value matrix. So this is done in order to increase the parallelism and having less consumptions onto the resource side. So we are having value up and value down projection matrix. And then the parameter size for this is 1.5 million, and in the same phase, like, we are having 1.5 billion parameter. So if we calculate all of these, so it will be Curie matrix plus key matrix, value up projection matrix plus value down projection matrix. And the parameter size, what it will be: 1.5 million plus 1.5 million plus 1.5 million plus 1.5 million, that is close to 6 million parameter. So we got 6 million parameters. Now what is being happening inside this, inside the attention? Okay, inside the attention, uh, inside the each attention head, attention head. So inside the, so whatever we have discussed, that is with respect to the single attention head. Single attention head. This is what, like, 6 million parameters inside the chat gpt, inside the GPT-3, that is with respect to the single attention head. Okay, but this is nothing, the inside the, let me mention, whatever we have discussed, that is with respect to single attention head. But in but in GPT-3 there are 96 heads. Okay, okay, 96 heads. Let me show. And how many attention heads are there in GPT-3? Okay, okay, just have a look over here. 96 attention head, right? 96 attention head. Attention head, that is 96 with respect to the 175 billion, and we are talking about the 175 billion parameters. So if in single head we are having 6 million parameter, what will be in 96 head? So total parameters in 96 head, that is 96 multiplied by 6 million, and it will be uh, around 600 million parameter. Okay, it will be around 600 million. Okay, now we are having 96, you can say, attention heads. Huh? Now, this is with respect to one attention block. Huh? In one attention block, there are 96 heads. Okay, you can think in this particular way. Heads are there. Okay, this is attention block. Just focus over here. Attention block. Single head, multi head, multi head, or multiple attention blocks. Huh? Okay, so let me show you this particular diagram. Huh? How many attention blocks are there? Huh? In GPT-3, or let me mention in this particular, generate a diagram with multiple heads and attention blocks for GPT-3. Okay. Okay. Meanwhile, what I want to say, we are having multiple attention blocks. In each and every attention block, we are having multiple heads, and multiple heads are the combination of, you can say, single head attention mechanism. So single head attention mechanism was having 6 million parameter. Okay, 6 million parameters was there, and we are having 96 attention heads. So 96 96 crores 6 million. Okay, this much, uh, that is close to close to 600 million parameter. Okay, now we are having multiple attention blocks. So in GPT-3 we are having 96 blocks. So this 96 crores 600 million. Okay, it will be around 58 billion parameter. Okay, that is 58 billion. So in this particular way, like the attention part, what we are able to see over here is contributing 58 billion parameter, 1.2 billion parameter because of the embedding matrix and unembedding matrix. 58 billion parameters are because of this particular attention block. And how we are able to get 58 billion parameters? Because of the query metric, key matrix and value matrix. Okay, so probably like we got the diagram, or you can consider this particular diagram. Okay, so what we are able to see, uh, you can take it in this way. These are the multiple heads, 96 heads are there. Okay, so these 96 heads are there. So first, like, the you can say, from this we got 1.5 million parameter. 1.5 into 96, it will be multiplied with 96 heads. In the same fashion, key vector, value vector, we will be having the output with respect to these attentions had multiple attention had. Okay, then what we are having, we will be having we will be having the output is given to the attention blocks. So 96 attention blocks are there, and from the 96 blocks, whatever the outcome what we will be having, that is, you can say, the 58 billion parameter. Okay, so that's what I have explained over here. And okay, so 6 million cross 96, so around 600 million parameters weight per block, and this is with respect to one attention block, but there are 96 attention blocks as well. 96 cross 600 million, that is 58 billion parameter now. So with the calculation what we have done so far, we are able to get 59.2 billion parameters from the embedding and unembedding matrix and from the attention block, and this is one third of the total parameters which are there inside the GPT-3. GPT-3 is 175 billion parameters, and so far we have discussed about one third of that, and two third will be from the multi-layer perceptron MLP, and that we will discuss in tomorrow's session. Okay, so hopefully you are able to understand. If you are having any doubt, you can ask. Vijay, Gurmeet, Raj, Vikas, Swati, Viranj. Any confusion, friends, that you are not able to get on? Anything? Are you able to get what we have discussed in today's session?
Yes, sir.
Viranj, Shivam, Vikas, anything that you are not able to digest, simple stuff, guys, simple stuff. Okay, if you are able to get the theory, that is more than enough. So inside the attention block there are three matrix: query matrix, matrix, and the value matrix, and each and every matrix is going to provide all of these, you can say three matrix are going to provide 6 million parameter, and inside this is with respect to one attention head, we are having 96 heads inside the GPT-3. So 6 million cross 96. So it is around 600 million parameters. And we are having 96 attention blocks. So 96 cross 600 million, that is around 58 billion parameter. So 58 billion parameter plus 1.2, so 59.2 billion parameter, and that is one third of the GPT-3 model. GPT-3 model is having 175 billion parameters, and that is one third of this what we have discussed, and two third will be from the MLP phase. MLP, you can say, the next topic what it will be, the MLP, and we will see the internals of MLP, and that is more or less same. We are having certain matrix multiplication over there, and with the help of that we will be able to get the more number of parameters, and we will see. And cumulatively, if we are talking about embedding, unembedding, attention, and the multi-layer perceptron, that will provide 175 billion parameter. Okay, so for the practice I'm going to share some notebooks. Okay, and you need to go through with those particular notebooks, and you need to try to run those particular notebooks and come with your observation. So in tomorrow's session probably I will ask to each and everyone like what you have seen with the help of this particular, that is the simple code. Okay, even like you type it onto the chat GPT or any other GenAI model, so you will be able to get the description, but the main thing is like what you will be able to get, that you need to explain. Okay, okay, I think we can conclude the session. That's it from my side. If you are not having any confusion or anything to ask. Let me stop recording.